you're able to join us for our AMA with Avi Kivity. My name is Bob, and I'll be the moderator today. And we'd like to keep this as informal as possible. We're just going to let everyone, kind of unmute yourselves if you have a question for Avi. If you prefer, you can use the chat feature down at the bottom of your screen. There's a Q&A feature. You can use that. We might even be able to let you share your screen if you want to show something or share something with the audience or with Avi. We asked just two things. One, if you can be mindful of when you're muted and unmuted. If you're talking and it's not part of the session, please mute yourself. We can go in and do that if need be. And then just be mindful of other people talking as well. Okay, we'll go ahead and get started. I'm happy to introduce Avi, though I think most of you know who he is as a CTO and co-founder at ScyllaDB, and a lot of you know him for his work for the KBM hypervisor. So we're very glad to have his time today. And let's just dive into some questions. We did get a couple of questions in advance. So maybe I'll start with one of those. If Avi, are you ready?
Yes, I'm ready. Go ahead, Bob. Thanks for the introduction.
Of course. So I'll start with one of the questions we got ahead of time, and it was pretty straightforward. Can I write a plugin to extend Scylla?
Yes, so good question. So right now, you cannot. We do have support for Lua, which can be used to write plugins, but we did not yet get any, prepare any extension points that you can actually use. You can only use them to write user-defined functions for now. But we do have Lua as infrastructure for plugins. So if you have an idea for something that you would need a plugin for, then just file an issue or write to the user's mailing list, and we can see if it's something that will be useful for many users. Then we can consider writing this extension point, and then you'll be able to write your plugins with our extension language, Lua.
That's great.
And I hope that answers the question for the anonymous submitter.
Well, I do have some other questions here as well, but let's check with our attendees. Does anyone have a question you want to ask? If so, just unmute yourself or go ahead and use the Q&A or the chat feature. Okay, well, why don't I go through one of the other questions we got ahead of time. This is an interesting one, Avi. What did you take from the KBM OSV projects to use in Scylla?
Yes, KVM and OSV taught us how to talk directly to the hardware and how to be mindful of every cycle and drive the efficiency. Especially KVM was designed for use on large machines, so we had to be very careful when architecting it for multi-core, and the core counts have only increased since then. So it both taught us how to deal with large SMP systems and also how to deal with highly asynchronous systems. And OSV is basically an extension of that. So we used our learnings from KVM to write OSV in the same way, dealing with highly parallel systems and trying to do everything asynchronously so that the system does not block on locks and instead just switches to do something else. And these are all ideas that we used in ScyllaDB and more in C-Star than ScyllaDB. C-Star is the underlying engine. And there is also the other aspect, which is working on a large-scale open source project. And we're doing the same thing here with a very widely dispersed team of developers. I think our developers come from around 15 countries. And this is something that we're used to from Linux and is a great advantage for us.
That's great. Thank you, Avi. I just got a note that apparently we did not have it enabled so people could unmute themselves. So now we do. And I'll ask again, anyone want to ask a question of Avi? Again, you can use the chat or the Q&A feature, or just unmute yourself and go ahead and ask. Don't be shy.
And not everyone at the same time.
Okay. Well, while you're thinking about questions, I'll go to the next one that we got ahead of time. Avi, it's, would you implement Scylla in Go, Rust, JavaScript if you could?
Okay, so good question. I wouldn't implement Scylla in JavaScript. It's not really a high-performance language, but I will note that Node.js and C# share many characteristics. So both are using a reactor pattern and designed for high concurrency. Of course, the performance is going to be very different between the two, but writing code for Node.js and writing code for C* is quite similar. Go also has an interesting take on concurrency. I still wouldn't use it for something like Scylla. It is a garbage collected language, so you lose a lot of predictability and you lose some performance. The concurrency model is great. The language lacks generics, so I like generics a lot, and I think they're required for complex software. And I also hear that Go is getting generics in the next iteration. So Go is actually quite close to being useful for writing a database or a high-performance database. It still has the downside of having a garbage collector. So from that point of view, I wouldn't pick it. It also, if you are familiar with how ScyllaDB uses the direct I/O and asynchronous I/O, this is not something that Go is great at right now. I imagine that it will evolve. So I wouldn't pick JavaScript or Go. However, the other language mentioned, Rust, does have all of the characteristics that ScyllaDB requires. So precise control over what happens. It doesn't have a garbage collector, so it means that you have predictability over how much time your things take, like allocation. You don't have pause times. And it is a well-designed language. I think it is better than C++, which we are currently using. So if we were starting at this point in time, I would take a hard look at Rust, and I imagine that we would pick it instead of C++ if we were starting now. Of course, when we started, Rust didn't have the maturity that it has now, but it has progressed a long time since then, and I'm following it with great interest. I think it's a well-done language.
Great, thank you. Thank you for that. Looks like we've gotten a couple of questions on the chat and Q&A, so I'll read this one to you, Avi. How does ScyllaDB Client Driver target a specific shard on target host node? Does it pick TCP source port to match target node NIC RSS setting?
Okay. So actually, we have an ongoing discussion about how to do that. So the scheme that we currently use is a little bit awkward. So what the client does is first it negotiates the ability to connect to a particular shard. So it just makes sure it's connecting to a server that has this capability. And then it just opens a bunch of connections which arrive at target shards more or less randomly. And then it discards all of the connections that it has in excess. So if it sounds like a very inefficient way to do things, then that's the case. But it was the simplest for us, and it did not depend on anything. So you don't need to depend on the source ports being unchanged. And because it is awkward, we are now considering another iteration on that. So what we're considering now is depending on the source port. And the advantage of that is that it allows you to open exactly the number of connections you need, and you don't have to open excess connections and then discard them, which is wasteful. But there are some challenges. One of the challenges is that perhaps not all languages may allow you to select the source port. And if so, they wouldn't be able to take advantage of that mechanism, and will have to fall back on the older mechanism. And the other problem is the possible problem is that network address translation between the client and the server may alter the source port. And if that happens, it stops working. So we will have to make it optional for users that are behind network address translation devices. I think the question also mentioned using the hash computed by the NIC, and we're not doing that. It is too hard to coordinate. Different NICs have different hash functions, so in the end it will be too hard. So right now we have basically a random connection to shard and then discarding the excess connections, and we are thinking of adding on top of that to using the source port for directing a connection to a specific shard. I hope that answers the question, and if not, just follow up with more.
That's great. We've gotten a couple more questions. Here's one that is, I'll avoid answering it myself. It's the benefits of ScyllaDB versus Cassandra. It'd be interesting to hear your take on this, Avi.
Okay, so.
Question we hear all the time.
Yeah, so, well, the number one benefit is, of course, the performance and the better utilization of resources. So you can accomplish more with less hardware, but there are also other benefits. We have the self-tuning facility, which means that you don't need to configure the compaction throughput or how much memory to allocate for various things. The database just decides on its own, and we're working very hard to make sure that it makes the right choices and adjust them as the workload varies. We also have some unique features like workload prioritization, which allow you to allocate server resources for different workloads. So you can decide that you want your online workload to have 80% of the server resources, and your analytics workload, which is less important to you, you can allocate it just 20% of the server resources. And what's nice about that is that if the online workload isn't using all of its allocation, it's 80%, then the analytics workload can take up the slack. So your system is fully utilized. You're getting what you're paid for from the point of view of the hardware. And if the OLTP workload, if the online workload goes back towards demanding more resources, then they are taken away from the analytics workload. So this is something that is quite unique to Scylla, and not just compared to Cassandra, but I think compared to most databases. We also have a new change data capture implementation, which is much easier to use than Cassandra's. The data is provided as a regular table that you can access via the driver using SQL statements instead of having to parse the log. So we've spent a lot of effort into making it easy to use. And there are many other benefits. We support the DynamoDB API, so you can not just replace Cassandra workloads. You can also replace DynamoDB workloads and get all of the benefits that ScyllaDB brings for a wide range of workloads, not just ones that migrate from Cassandra.
That's great. Thank you for that, Avi. And I'll add that, there's lots of resources on our website comparing Scylla with Cassandra in any number of aspects between benchmarks and implementations. And so you can just do a search on our site for that. We got another question here, a couple of questions from Siva. Any plans for releasing ScyllaDB on Azure and or GCP? And I'm not sure, Siva, if you meant Scylla Cloud specifically or just our plans for Scylla in general. I'll put that to you, Avi.
Okay, so I'll just address both. So first, you can install Scylla on Azure or on GCP. We don't provide images right now, so it's a little bit more work. You have to select an OS image and then follow the installation procedure just as you would for on-prem. So it's a little bit more work than necessary. And we are working to provide images, which will save that work, and you will just be able to select the Scylla image from the marketplace and launch it, and it will start working immediately. And the other half is Scylla Cloud. We are working on GCP and Azure. I think that GCP is the one next in line. I don't have the timelines, but we're trying to do it as quickly as possible so that people can use Scylla, especially people who are migrating away from Amazon and want a replacement for Dynamo. They can find it in ScyllaDB running on GCP.
Thanks for that. We've got another question here. Do you plan at some point in the future to support an alternator? An alternator is our DynamoDB compatible API. To support an alternator, the feature of DynamoDB transactions.
Yes. So, well, DynamoDB has the two kinds of transactions. The first kind is a transaction that is within a single item that is already supported. It's implemented on top of our lightweight transactions support that's used for regular CQL operations. So that's already supported. There is another kind, which is a multi-item transaction, and that we do plan to support it, but that is still in the future. It's not a short-term implementation work. So what we're doing right now is implementing Raft, this the kind of infrastructure for transactions, and then we will implement alternator transactions on top of those of the Raft infrastructure.
Great. Those are the questions that we have submitted via chat and Q&A. I'll ask again, if anyone wants to unmute themselves and ask a question, feel free to do so, or again, you can use the chat and Q&A. And I'll say as people are thinking about their questions, we're going to continue to do these kind of very informal AMAs with Avi, because it's interesting. We just want people to have the opportunity to pick Avi's brain about our project or projects that they're working on. So we'll let you know about the next one coming up as well. Avi, we don't have any other questions. Is there anything that comes to mind that you want to raise with people?
Not really. I'm here to answer people's questions, and that also includes questions about your particular workload. So if you have some kind of problem or question about how to use Scylla with a particular workload, so of course you can do that on our Slack channel or on the mailing list, but it's also possible to do it online here or in one of the future sessions, and we can utilize this medium as well.
Great.
Is it time for another question?
Yeah, please.
So Scylla and C start to the approach of dynamically allocate memory, other HPC product sometimes choose the approach of pooling objects and pre-allocating the object ahead. And I want to hear if you have any thoughts about the difference between the approach. Did you consider the pooling approach for ScyllaDB? Why did you choose this memory allocation approach?
Okay, so interesting question. Basically, the approach of having object pools works when you have very regular workload. In Scylla, the workload is very irregular. You can have a workload that has lots of reads with, I don't know, 40-byte objects, or you can have a workload that has 1 megabyte objects, and you can have simple workloads that just do a single partition reads and write, and you can have complex workloads that use indexes and indirect via indexes and build materialized views. So the pattern of memory use varies widely between different workloads. And if you had a pool for everything, then you would end up with a large number of pools, most of which are not in use. And the advantage of dynamic use of memory is that you can repurpose all of the memory. The memory doesn't have a specific role attached to it. So, and this is even dynamic. So the workload can start with one kind of use for memory and then shift to another kind of use. We don't even have a static allocation between mem tables and cache. So if you have a read-only workload, then all of the memory gets used for cache. But if you have a read-write workload, then half of the memory gets used for mem tables and half of the memory gets used for cache. And there is also working memory that is used to manage connections and provide the working memory for requests in flight, and that is also shared with the cache. So if you have a workload that uses a lot of connections and it has high concurrency, then that memory is taken from the cache and used for those to serve those requests. And a workload that doesn't have a high concurrency can, instead of having that memory sitting in a pool and doing nothing, that memory is part of the cache. So the advantage is that everything is dynamic and you can use more of your memory at any given time. Of course, it results in a much more complex application because you have to keep track of all of the users of the memory and make sure that you don't use more than 100%. With pools, it's easy. You take your memory and you divide it among the pools. But if you have dynamic use, you have to be very careful to avoid running out of memory.
Great, thank you. So we've got a few more questions here. I'll go through these in order. Avi, is it true Scylla uses C++20 already?
Yes, we're using C++20. We switched, I think it was about a month ago. Now the features that I was really anxious to start using C++20 for is coroutines, which really fits very well with the asynchronous I/O that we do everywhere. So it promises to really simplify our code base, but that feature is not ready. So we're waiting for some fixes in GCC in the compiler. So as soon as those fixes hit the compiler, we will start using coroutines. But the other C++20 features are already in use and we're enjoying them.
Next question, it's being said that wide column storage is good for messenger-like applications, high frequency of small updates. If so, could you explain why? Would ScyllaDB work better than MongoDB for such workloads?
Okay, so first I have to say that I think that all this labeling of wide column storage is a misnomer. So it comes back from the days, the early days of Cassandra, where it was schemaless, and you would allocate a partition, and you could push as many cells as you wanted into a partition without any schema, and those would be termed the wide column. But these days, both Cassandra and Scylla don't use this model. Instead, you divide your partition into a large number of rows, and each row has a moderate number of columns. So it's not really accurate to refer to Scylla as the wide column. Of course, the name stuck, and it's impossible to make it go unstuck. To go back to the question about whether it fits a messaging application. So yes, we actually have Discord was a very famous messaging application using Scylla. So if it's a good fit for them, then it's a good fit for any messaging application. Comparing to Mongo, I don't think that the problem is the data model. It's really about the scalability and the performance. If you have a messaging application that has a high throughput, you have a high number, if you're successful and you have a high number of users, then you need to use something like Scylla in order to scale. If you have a small number of users and you don't have high performance, then anything will work. And it really depends on whether you hit high scales or not.
Right. We've got another kind of comparison question. Jonathan's asking, can we compare ScyllaDB to Aerospike? Excuse me, Aerospike. Do they optimize for the same use cases at all?
Yes. So Aerospike is, and in some respects, similar to Scylla. I would say that the main differences are that Aerospike is partially in memory. So Aerospike has to keep all of the keys in memory, and Scylla does not. So that allows Scylla to address a much larger storage. If you have to keep all of the keys in memory, then even if you have a lot of disk space, as soon as you exhaust the memory for the keys, then you need to start adding nodes. Whereas with Scylla, we support a disk to memory ratio of 100 to 1. So if you have 128 gigs of RAM, then you can have 10 terabytes of disk. And there are, of course, servers with more than 128 gigs of RAM. So we do have users who are running with dozens of terabytes of disk. And I think this is something that Aerospike does not do well. I'm not an expert in Aerospike, so don't take me up on that. But my understanding is that this is a point where Scylla would perform much better by allowing this kind of workload to be supported. If you have a smaller amount of data, then I think they are similar. I think that we have a much wider range of features, so we support more operations than Aerospike, better cross data structure, data center replication. But again, I'm not really an expert in Aerospike, so I can't say a lot about that.
Okay. Thank you for that. Next question, does ScyllaDB also support persistent memory? Any performance comparisons performed with regular RAM or maybe PMEM as cache or future work planned?
Oh yes, so we did do some benchmarks with persistent memory. I think it was a couple of years ago, and you can probably find them on our blog. We did that with Intel disks. We currently don't have anything planned for persistent memory, and the reason is that it's not widely available. So you can't find it easily. Of course, you can buy it if you want, but you can't just like go to a cloud and select an instance with persistent memory. When it becomes widely available, and then sure, it makes a lot of sense to use it as a cache expander. And this way you can get even larger ratios of disk to memory, and so improve the resource utilization. So it is very interesting for us, but it doesn't have enough of a presence in the market yet to make it worth our while to start optimizing for it yet.
Thank you for that. Next question is from Diego. What's the status of Clang MSVC compliance? Is it something you're on?
Okay, so Scylla does compile with Clang. We have a developer that keeps testing it and sends patches every time we drift away from Clang. Our main compiler is GCC, but we do compile with Clang, and things that recently, because of some gaps in Clang's C++20 support, we drifted away. But I imagine that as soon as Clang comes back into compliance, then we'll be able to build with Clang again. MSVC is pretty far away, and the reason here is not the compiler, but the ecosystem. So we're heavily tied into Linux. I imagine that we could port C* to Windows, but there really isn't any demand for running ScyllaDB and other C* applications on Windows. Linux is really the performance king for such applications. So this is where we are focusing. It could be done. So if you're interested, you can look at porting C* to Windows. But I don't really know about how, in terms of the compiler compliance, whether MSVC is there or not. I hear that they're getting better lately, but I don't have any first-hand knowledge.
Before I ask the next question here, I'll remind you, Avi raised a good point earlier, and that's that you can ask questions specific to your deployment. If you're running or experimenting with Scylla and you have a specific question, we're getting broader type questions, but if you have a specific question, feel free to ask that as well. Next question here is, does Scylla support running on AWS Graviton 2 instances? If so, what's your insights, experience on performance comparisons between those instances with AMD/Intel instances, specifically for the Scylla DB workload? Okay,
interesting question. So we did run benchmarks on ARM systems, not on Graviton, but on ARM systems. And Scylla builds and runs on those ARM systems. The Graviton 2 instances that Amazon is providing are not really suitable for Scylla because they don't have fast NVMe storage. And of course, we need a lot of very fast storage. So you could run Scylla on EBS, Elastic Block Service, but that's not really a good performance point for Scylla. Scylla really wants fast local storage. So when we get a Graviton-based instance that has fast NVMEs, then I'm sure that Scylla will be a really good fit for it. And we will support it. So we do compile on ARM, and we work on ARM without any problems. As to whether it will work well, it will. So the shared nothing architecture of Scylla works really well with the ARM relaxed memory model, and it really allows the CPU to it gives the CPU maximum flexibility in how it issues the read and write request to memory compared to other applications that use locking. So we do expect to get really good performance on ARM, and we did on the benchmarks that we performed in the past, and I think they are on our website as well. So as soon as there are ARM-based instances with lots of fast storage, then I expect we will provide AMIs or AMIs, I forget how it's pronounced today. And you will be able to use them. And even now you can compile it on your own for ARM, and it's supposed to just work.
Thanks for that. And while we're waiting for the next question, I'll tell everyone that we'll follow up with everyone that's attended today just to get your feedback. You know, is there something you would like to continue to do these, but if there's you know, a change to the format or a way we can make this easier for you, please let us know. I think it's great that Avi's able to answer some of these types of questions. And I'll put it out there again. Does anyone want to unmute themselves and ask a question or use the chat or the Q&A? Here, we've got another question here. Avi, does every mem table have a separate commit log? I assume yes. If so, how are these commit logs spread among the available disks?
Okay, so your assumption was incorrect. We have a shared commit log for all of the mem tables within a single shard or a single core. And the reason for that is to consolidate the writes, so that if you have a workload that writes to many tables, then instead of having to write to many files, we just intersperse the writes of to all of those mem tables into writes for a single file, which is more efficient. But we do have a separate commit log for every shard or for every core. And this is part of the shared nothing architecture, which tries to avoid any sharing of data or control between cores. So generally, the number of commit logs is equal, the number of active commit logs is equal to the number of cores on the system. We keep cycling between them. So you have, there is one active segment, and as soon as it gets filled, we open a new active segment and start writing to that.
Any other questions? We've got some really good questions today. Some we didn't expect, some we did. Any other questions people want to ask? We won't necessarily keep this live until the top of the hour. So put it out there. Last opportunity to ask a question of Avi. We're not sure how often we'll do these AMA sessions, but we'd like to do them regularly. So we'll notify you before the next one, and you can submit questions ahead of time again, or just come prepared with questions. But I'll put it out there again. Any last questions?
Can I ask another question?
Yes, please, Elazar. Go right ahead.
I want to ask what Scylla's approach of debugging issues from the field. Scylla, did you rely on logs or on traces? How do you debug issues that doesn't recreate on your machines that comes from clients?
First of all, it's hard. So there's no magic answer for that. We have a tracing facility that can be enabled dynamically. All of the interesting code paths are tagged with kind of dynamic tracing system that you can select a particular request for tracing, and then all of the code path that touches that this request touches log some information, and that is stored in a Scylla table, and then you can use that to understand what went wrong. There is also a regular log with variable levels, which is pretty standard. This has limited usefulness because you cannot just open the log for debug mode, because if you have a production application that is generating a large number of requests, it will quickly spam the log, and it will also impact the request, the running request. So there's no magic answer. Sometimes tracing works. What we do go to is the metrics So the metrics don't give you any direct information about a particular request, but they do give you a very good overall picture about what the system is doing, the state of various queues, where memory is allocated, the rates at which various subsystems are operating. And there's a lot more than just metrics that we expose in the dashboard. If you go to Prometheus, then you have access to, I think it's in the thousands now, thousands of metrics that describe different parts of the system. And we use those to gain an understanding of what the customer system is doing. And from that, we can try to drill down via tracing, or maybe by asking the customer to do different things. In extreme cases where we're not able to make progress, we will create a debug build that with special instrumentation. But of course, we try to avoid doing that. That's an expensive way to debug. We prefer having enough debug information in advance present in the tracing system and in the metrics.
That's great. We've got a kind of a follow-on question here. How do you debug C-star application of this size? I considered C-star for my pet project, but it looks virtually undebuggable.
So it's not undebuggable. It does have a learning curve. So it takes time to learn how to debug it, but once you do, then so you need some experience and expertise. We rely a lot on the sanitizers that are part of the compiler. So if you run the application in debug mode, then it finds memory bugs with high precision. It also pinpoints the problem, so it's easy to resolve. And we are adding debug tools. So we have error injection tools in ScyllaDB and also in C-star. And we use those to try to flush out bugs before they hit users and customers.
Great. I'll ask, let's try just one last time. And any other questions people want to ask, either unmute yourself and ask, or you can use the Q&A feature. And if not, then we will wrap up this session. Again, we'll look for feedback from you, how we can make improvements for the next session, and we'll let you know when that session is. Last chance for any questions of Avi?
I have a follow-up question to the commit log question.
Sure.
So if there is only a single commit log for multiple mem tables, won't it cause for interleaved workloads that, for example, a lot of writes happen to only one mem table and then a single write to a different mem table? Won't it cause it to flush both mem tables? How do you process this interleaved entries for different mem tables in a single commit log?
Okay, so it's a good point. So it can cause early flushes of mem tables, but the way we handle it is simply by being very generous with the allocation of space to commit log. So our commit log can be as large as the memory size, and our mem table is limited to half the memory size. So in practice, the mem tables flush because they hit their own limits before you get this kind of forced flushing. So in theory, it is possible to get forced flushing, but in practice, it's never been a problem. Just by being generous with disk space, it's easy to be generous when it's your user's disk space, but really when you have, usually you have disk space that is several dozens of times larger than memory. So you're just sacrificing a few percent of your disk for commit log.
I see. So the answer is basically that you hopefully never reach the situation that you actually run out of space for the commit log to flush all the entries, and you hope that until you get to that point, then you would flush all the previous contiguous mem tables anyway, right?
Yes, and that's what happens in practice. Because the commit log is larger than memory, then some mem table reaches its limit and starts flushing. And it is possible for what you described to happen, but it is not so bad. So it's okay. So you have a mem table that is flushed a little bit earlier than it otherwise would be. It means that there will be a little bit more compaction later, but in practice, it's never been a cause of a problem.
Okay, thanks.
Okay, unless there's any other questions, I think we'll wrap up for today. I'll remind everyone that we are very responsive on our Slack channel. So if you have any other questions, our support team is very responsive. And I'll thank you for joining today. Avi, thanks for your time, and we'll let you know when we have the next session. Okay.
Thanks, everyone.
Thank you,
Bye-bye.
everyone.